You know how much of a pain in the ass it was to get the right answer the first time?
Oh,
Well, yeah, I can only imagine
That
the
was
interview
worse.
that
I went
started
back
that.
and forth with engineering and Vadim on this many times to get this right.
I'm just glad you got an answer.
So, yes,
Wow.
that is an educational piece of information that doesn't necessarily change anything that you need to do, but to know it, I think is gold.
Well, it helps you answer questions.
It does.
Right.
Yep. How does this feature work? Well, this is where it changes.
Well.
This is where, doing this and, yeah.
If I were to stand on my head during a full moon in the second week of the month, would I have
Yes.
a response back?
But only if it was a time that ended in a 2.
Yes. Right. And even numbered times on the clock.
And then, look at this. I have another one for RPZ. So basically the same, showing all the different possible actions, all that kind of stuff. That one's a lot simpler.
Yeah.
And then I have one for DHCP.
But that's just standard, isn't it?
Yep.
Okay.
Yeah,
I mean,
pretty
that's the typical.
Yeah.
Okay.
Nothing. Yeah.
Nothing proprietary in there. Just
No.
that's how it works.
Yep. And then if I go back here, this is different options for how DHCP failover might work, and this is the Anycast one in an active-active. So scenario 1A, the peers are deployed across 2 sites. So locally, and this is important, this is worth knowing, the laptop sends a broadcast. When we're configured for Anycast on the DHCP server, it no longer listens to broadcasts. You now must relay to it. So the broadcast is ignored by the DHCP server and the relay sends you back to the box.
So you have to have a relay configured
You
on.
have to have a relay.
Subnet.
Because if that server was down anyway, you'd still have the relay sending the packet to the remote
Oh, okay.
system. The only difference is explicitly this box does not listen to broadcasts. It only listens to unicasts. That's a pretty big distinction.
Yeah.
So,
Right.
sorry, so you're saying if you put any cast on a blocked one host, but it won't respond to a broadcast.
Correct.
Thank you. Because I've installed, I've got a NIOS running at home. Runs fine. DHCP no problem. But I was playing around my blocked one.
If
host.
it's Anycast DNS, then it still listens locally. If it's Anycast DHCP,
No, but it's
then
the-
it does not listen
But
locally.
it's for DHCP and it just doesn't work on my blocked one host. I'm looking at it thinking, well, why
Did you
not?
do an Anycast address for your DHCP
Yeah,
server?
yeah.
Yeah, that's why.
Yeah.
Yeah, that's why. Right there. And then if
One of
this
those
system
things
is
I'll never
down
forget.
for
Yeah,
whatever
exactly.
reason, packets go across. You have your Anycast group. This one here, it won't listen. Packets are not going to go there. Packets are not going to go there. So yeah, and this just kind of describes it. This is the recommended scenario, A or B, doesn't really matter.
Okay.
Right here, site 1, send Anycast IP. Basically, it's the same as, got to go through the relay. But then this guy comes over here if the local DHCP is unavailable, right? It's all routing at that point.
Yeah.
Right? That's pretty straightforward. Now, what if I had DHCP at the same site? Possible with conditions, and Anycast should be deployed across sites. Watch. So, laptop does a broadcast, relay forwards it on. You have a DHCP Anycast group. So you have both of these servers in the same location, and they're both advertising the Anycast address, which means you're likely not going to end up in a situation where you can do different costs or different metrics, which is highly likely to create issues. And notice here, DHCP number 2 must have a higher cost route. Must. So you got to find a way to make that work, right? Same thing on the other side. Now, if subnet 1 goes here and subnet 2 goes here, is that okay? Yes.
Kinda.
They're different subnets.
Well,
We just don't want this client going here and another client going here.
do the boxes keep track of the fact that do they synchronize?
Yeah.
Okay.
But they do it asynchronously,
Right, okay.
so. And then for a client renew, it's just an Anycast packet in, Anycast packet in, and at that point, it doesn't matter, because I'm renewing, and either one can renew me, it's irrelevant. It's only on the Discover, the DORA, that I have to have persistence to the same server. In DNS, if I send an Anycast address or to an Anycast address and he responds, gives me an answer, my very next query can go to somebody else. I maintain all the state. I maintain everything I need to maintain. DHCP is like, I come to you, you give me an offer. If I go to you for the request, you're like, what the hell are you talking about?
Right, yeah.
So I have to go back to him for the request. That persistence has to maintain across multiple messages. That's not how it works in DNS. And so this is why I say, if somebody has never touched Anycast before, they haven't even done it with DNS, they should not be doing it with DHCP, because it is a different beast. And you might run into problems with it
I'm
not
just
working the way
trying
you
because-
expect it to work.
Because, yeah, that's exactly what I did.
Yeah, I think, so this one is just basic, back and forth for Discover packets and how they work across different environments. You notice again up here, in a DORA, the Anycast DHCP server won't listen to it, so there's nothing happening. But if you go over to this side, the relay is what allows the process to continue. And then down here on the renew, it doesn't really matter because it's a unicast message, so
Right.
it'll be handled. So that's Appendix H.
Thanks for that.
I think H and B and A, maybe D, A, B, D, H are probably the ones I go to most. I drew them all up, but I don't have many situations where I'm going to go in and look at B1 DDI with NIOS, and this one is really just more a reference to a migration. So if a customer was going to ask, kind of like a little bit about how something might work, there's the pre-migration, migration, post-migration. And then what happens when I'm doing DDNS? I send it to myself, most likely. That's the default for Microsoft. They set their default resolver to 127.0.0.1, which is the smartest thing in the world. And then with Blocks 1, they just communicate with Blocks 1. Why is sending it to the loopback not smart? It's AD. AD depends on DNS. And if it's AD and it's DNS in AD. So what comes first, chicken or the egg? So AD boxes take an extra 5 to 15 minutes to boot because it points to itself for
They're
DNS.
talking to themselves for so long.
It's waiting for DNS to start.
Gotta wait till you
And
come
DNS
up.
can't start because the whole AD system can't come up.
Right.
Yeah.
And so it just waits for timeouts, and then finally it comes back up after all the timeouts, and then it starts doing its thing. Whereas if it pointed to another system, even if it pointed to another Microsoft system, that sucker boots like super quick. We do A here. What time is it?
1:45.
1:45.
All right. After this one, I'll stop and we'll go back to that. All right. So this one here, this one I like because it shows resolution paths. So in this one, Blocks 1 DNS is secondary auth. The intention was to effectively identify that this would be NIOS as the primary, but it could be anything. It doesn't matter. Mobile device, whatever client sends a packet, from 1 to 2 to 1, it sends a packet from here to the DNS server. DNS server has the answer because it's authoritative response back. Pretty straightforward. right? Oh, by the way, this is how my little action menu thing works. I click on this and it changes pages for me automatically. Or
What was that
changes
again?
layers or does whatever.
What was it, do that again?
That's the action box.
That action box up in the top corner,
Yeah.
So
I
how
click on it and it changes pages.
is it pseudocode like show layer X?
It's basically a on-click, do this,
Okay,
hide or
on-click.
show.
Okay.
That's all it
That's
is,
all it
hide or
is.
show.
Okay.
And it can hide or show pages or layers.
Oh, okay.
Yeah.
Cool.
So anyway, so then what if what if a client wants to go to the internet? So the query goes from the client to Box One, and then depending on whether or not you have threat defense, it goes up here. Otherwise, or if it has internet breakout, it just goes there, or it just goes there in general. So this is the communication path. 1 to 2, 2 to 4 if it's a forward secure path. That's what this is a forward secure path. That's the terminology. Versus an internet breakout secure path, right? And that's the terminology. If you're not, if you don't refer to it that way, please refer to it that way. We spent a lot of time coming up with those. But you'll see that the path is 1 to 2 to 4 to 5 to 4 to 2 to 1. Right? So this entire communication flow is intended specifically to show you what the traffic flow is. This was all done before I did that big ass workflow,
Yep.
but I think this is simplistic comparably. And this little yellow box is just to